Hello dear students, today we will solve the ISI JRF Economics. So here we got a question as usual, almost a very large question. So let's read it, it'll take some time. So consider an economy that potentially accommodate money. There is one single good and and the nominal price of the good at price T is given by PT. So this economy is inhabited by agents who lives in two periods, but the economy lives for eternity. These agents are each endowed with Y units of the good and the first period of they are young and earn nothing as the second period of the life when they are old. These agents live no bequest nor inherit any. So the total stock of the goods of each period is sufficiently exhausted through the distribution among the young of that period. So at any time t, the population consists of n young and n old agents, and this is the u. CYT and C20 denotes the consumption of the agent who is young at the time t and the consumer at 1t plus 1. Agents can potentially carry over the first period endowments to the second period. Second period is 1 plus sigma times they carry in the first. Delta is greater than minus 1. A young agent in the time period t either consumes our endowment in youth or stored at part of it in ST, in which ST 1 plus sigma to our in period t plus 1, or trade it for the money MT, where MTD denotes the demand for money. So the agent has MTD by PT, amount of the real balances at the end of t. So the budget equation of the agent who is young and t for this according to given by this value. So the an old agent gets money transfer from the government and the real transfer from an agent, old agent t plus 1 implied by the money transfer in the t plus 1. So this is the total relationship. So we need to show that the rate of inflation for t, then young agents will never use the storage mechanism to carry any portion of the first period endowment to the next period. So we have this equation here, very important, using this, that ST equal to 0. So this delta, substituting the expression in the MTDT form of this thing, so y will be CT of y ED and PT. Okay, so the agent's utility function is u equal to log of CT of y 1 by 1 plus rho log of PT plus 1. The agent maximizes the utility subject to the budget constant. Since the budget constant doesn't involve storage, so the agent will not use the storage mechanism if it doesn't increase the utility. So this was the first. Okay, next assume that pi t less than delta, solve for CT and MTD in terms of YT and TT. Okay, so now y is equal to, for part 2, y equal to, sorry, no, only y equal to CT of y PT y minus CT of y. Using the expression, the utility function will be reformed now, ln CT of y rho ln y CT of y t plus 1. To find the optimal consumption CT of y, we maximize u with respect to CT of y by taking the derivative of u and setting it to 0. So 1 by CT of y is 1 by 1 plus rho y CT of y plus t, I guess t plus 1 by p t plus 1. This is the first order conditions, first part, and from this thing we can see that t plus 1, this is y, so substituting this ct of y in the budget constraint, we get that this by pt is y t plus 1 pt plus 1 plus rho. So finally this will be yp okay. This is the second answer. Third answer is assuming that the money transferred from the government is financed through the seniorage, and tt plus 1 here is mt plus 1 minus mt pt plus 1 denote, and so the money supply and the price level of the period t plus 1. Further, suppose that the government follows simple monetary rule given and this alpha, so such in this case the money is held in the equilibrium, so money supply alpha and beta, and the voltage is money false. Okay, so let's just calculate this. So tt plus 1 mt, and so mt plus 1 is so this we have so tt plus 1 is alpha mt pt plus 1, substituting into the expression of mtd in the part 2 actually, so this will give us pt is y rho alpha mt divided by 1 plus rho. So in this equilibrium, mt of d pt is mt by pt, so we can write mt by pt t plus 1 plus rho. Solving this equation mt by pt we get, so this mt by pt is directly mt with respect to pt we can find out. Okay, so mt equal to rho so therefore the equilibrium money supply is this. Now this has two sections, A and B. So equilibrium rate of inflation, part A, equilibrium rate of pi t pt plus 1 minus pt by pt. So we put these values over here, and with a little bit of calculation we can write pi t is yp plus alpha, and in the second case equilibrium of the real consumption in the voltage is given by mtt by pt and tt plus 1. So we will be putting this value again. pt plus 1. Putting this value and doing a little bit of calculation will lead us to alpha pt. So as now pt plus 1 is equal to 1 plus pi t into pt. So here ct plus 1 is plus alpha 1 plus pi t into p t. So here also we do a little bit of calculation and directly after yp 1 plus rho is 2 alpha and pt. So if the government increases alpha, then the growth rate of the money supply will increase, and from the above equation we can see that the equilibrium real consumption in old age falls as alpha increases, since the numerator remains constant while the denominator increases. And that's the end of this question.